Let's get started with question number 1. We are given 3 coplanar forces. Their magnitudes are these, and they're given sine alpha is 3/5. Whenever they give sine alpha, that means they want you to use this exact value. Obviously, in these coplanar forces, we will also need cos alpha. So let's try to evaluate cos alpha with this. Then they are saying find the magnitude and direction of the resultant of the 3 forces. First of all, let's find cos alpha. If this is alpha and sine alpha is 3/5, 3 is opposite. Phi is hypotenuse. So we can find the third side, let's call it x by Pythagorean theorem. So 3 square plus x square equal to 5 square. So x will be square root 5 square minus 3 square. I hope you understand this, and that gives us x equal to 4. And this will be used whenever needed. All right, let's do the next thing. Next thing is the forces which are inclined, they will be broken into components. This 8 Newton is inclined, but we don't know the angle. 6 Newton is also inclined, and we know the angle. Wherever is the angle, that component becomes the cos component. 6 cos alpha. There is nothing called cos component. It is called y component actually, but I call it cos because it emphasizes upon the idea that wherever is the angle, whichever component is making angle, that we write as cos. The reason behind this is in one of my videos. You can scan my channel for this. The other component on the other side will become 6 sine alpha. But we don't know angle with 8 Newton. But what we know is that this angle is 90 degree, right? So we also know that this angle is 90 degree, don't we? That means this angle will be 90 minus alpha, right? And since this is a right angle triangle, this will become alpha by the same logic. So let me undo and make it cleaner. And we know that this angle is also alpha. So now we can write the components of 8 Newton. Here it will be 8 cos alpha because angle is here. This becomes 8 sine alpha, right? And next step should be to find the resultant. For resultant, we need 2 resultants. Resultant in x direction, resultant in y direction. In x direction, what will be the resultant? There are 2 forces on the left side, 7 Newton on the right side. So let's make this as 8 cos alpha, the left one, plus 6 sine alpha, again left one, but 7 Newton is on right side, so it will become negative, opposite. I'm assuming that these 2 are more than 7, so resultant, if it is positive, will be in left direction. All right. So let me shift this little down and let's evaluate this. 8 cos alpha. We know cos alpha is adjacent over hypotenuse, 4/5. Plus 6 sine alpha, 3/5. Minus 7. That will be 32/5 plus 18/5. 32 and 18 is 50/5. 50/5 minus 7, that is 10. 3 Newton, and it is positive, that means it will be towards left. So it comes out to be 3 Newton to the left side. Okay. Let's go to the RY component. RY, we need drawing for that. So 8 sine alpha upwards, 6 cos alpha downwards. 8 sine alpha upwards and 6 cos alpha downwards. So let's evaluate this also. 8 times sine alpha, 3/5, minus 6 times 4/5. So 8 times 3 is 24/5 minus 20/5. Wow, that is 0 Newton. They are equal. There is no force in y direction, resultant force. That means it becomes so easy now. we have a force, resultant force Rx is actually your resultant force, which is 3 newtons, not to the right, it is to the left. Yeah, that's what we got, left. 3 newtons to the left. So we found the magnitude as well as direction. That's it. Particle P moves in a straight line starting from point O. So here time is 0. We're starting from here. Displacement is also 0 from O. At the time t after leaving O, the velocity is given as this. So this is the equation for velocity. Find the two values of t for which p is at instantaneous rest. So they are not saying that it is starting from rest. It can be somewhere else. So for finding it to be at rest, rest being on rest means velocity is 0. Just make this equal to 0, and that will give us when it is at rest, means it is stopping. So just factorize this particular expression and it will give you the 2 times. You can use your calculator directly. The marks are 2, so let's do some legwork. So I got these two factors and they will give us 2 times. So 2t minus 1 equal to 0, t becomes half a second. This gives us 2t equal to 3, which is 3 over 2. Let's visualize this on the drawing. After half a second, it turns back. So here t is half. Then it goes, maybe it crosses 0, I'm not sure, but let's see, it crosses and then turns back when time is 3 over 2 seconds. And there is no other turning point. This is how I'm visualizing this. But what is the question? Question was find the two values of t, and we found the two values of t, t over half and 3 over 2. Okay. Find the distance traveled by p between these two times. That means it turns here and here. This distance they're asking, let me change the color which will be making it visible. This distance, only this distance they're asking. So for distance, we should have a distance formula. We don't have. So to find displacement, we will just integrate the velocity equation, which is v dt equal to 4t square minus 8t plus 3 dt. Okay, since it's a straight line, from t equal to half to t equal to 3 over 2, it's a straight line. That means direction is only in one direction. So there's no problem in writing half and 3 over 2 here. If there was a turning point in between, then there would be a problem. Since there is no turning point, we can straight away put these values here. So let's integrate this one, which will be 4t cube over 3 minus 8t square over 2 plus 3t plus c, from half to 3 over 2. And now just substitute the values one by one and we'll get it. 4 3 over 2 cube over 3 minus 8, 3 over 2 cube over 2 plus 3 over 2 plus c minus 4 half cube over 3 minus 8. I hope you understand. I'm just substituting t with the two values and subtracting like a normal integration. 9 over 2 you can write straight away here plus c. C and C is the first thing we cancel out and put this whole thing in a calculator and you will get the displacement. If displacement comes out to be negative, which is expected because it is changing the direction, we'll make it positive. Let's see what my calculator gives to me. What I get is mere 2 over 3 meters. So simple. Okay, let's go to the next one, which is this. A particle of mass 8 kg projected with a speed of 5 meters per second up line of greater slope on an inclined plane where the angle is alpha. Okay, so this is alpha, and from here u initial velocity is 5 meters per second. All right, and sine alpha is 5 over 13, and as I told you in first question, just interpret this into cos also, that will be needed maybe. So this is alpha, opposite is 5, this is 13, and if I use Pythagorean theorem by the same method, I will get the third side as 12 centimeters, rather meters. Okay, so this is what I'm getting. I will use it. Let's go ahead with the question. The motion of the particle is resisted by a constant frictional force. So if it is going this way, there is a friction force in opposite direction. All right, and magnitude is 15 Newton is given. Frictional force is, let me write straight away, 15 newtons, not FF. So 15 Newton is the resistive force. The particle comes to instantaneous rest after traveling a distance of x meters. So it goes up the plane and stops somewhere here where v is 0. U is 5, v is 0. Express the change in gravitational potential energy of the particle in terms of x. So change in gravitational potential energy is mg final height minus initial height. Mass is 8 kg, g we know is 10. Final height is this one, which will be h, let's call it hf, right? This is hf. So sine alpha equal to hf over the total distance it traveled was how much? X. So sine alpha is given 5 over 13. So 5 over 13 x is equal to the final height. So we'll write here 5 over 13 x. What was the initial height when it was thrown up? It was thrown from the ground. So there was no height, 0. So answer comes out to be 8 times 10, 80, 80 times 5, 400 over 13 x. This is, you can write the unit joule also. This is the difference in potential energy. Use an energy method to find x. So look here. There is no applied force. It was just thrown and there was no other force that was being applied to it. So the energy equation says the change in potential energy plus change in kinetic energy is equal to the work done by applied force, which is nothing here, minus work done by the resistive force, right? So delta PE we just found 400 x over, 400 over 13x. Delta KE, let's do delta KE rough work here. Delta KE kinetic energy change is half m Vf square minus Vi initial square. So half, mass is 8 kg. Final velocity they said 0. Yeah, it stops finally. Initial velocity, it was thrown, projected with 5 square. So it becomes 2 and 8 can cancel, 4, and this is 25. Minus 25 times 4, 100 joule. Right. This is the loss of kinetic energy. So we will write minus 100 joule is the change in kinetic energy, which is equal to, there is no applied force, so 0, but there is a resistive force, which is 15 newtons. Okay, so resistive force will be the force 50 Newton multiplied by the distance it travels, which is x. Force, we know that work done is force times distance. So resistive force is 50 Newton, distance it travels during that force is x. That's what it is. And obviously they might be asking what is the value of x, and we'll do that now. So This is x, this is x, let's put them together. 400 over 13x plus 15x equal to 100 will come to the right side. And let's add them 165, 6, 195. 595 over 13x equal to 100. X equal to 100 multiplied by 13 divided by 595, which will be 2.184 meters. So we will add just three significant figures, 2.18 meters. Next question number 4. A VT graph I can see here, and they are explaining this motion here. They're asking us to calculate the distance covered by the sprinter in first 42 seconds. Whenever there's a VT graph and we have to find distance during some of the sections, we just find the area under those sections. So basically we have to find the area of this shape, which is a trapezium, right? So let me find what we have here. Let's see. Area of a trapezium. Okay, is half the first parallel line. This is the first parallel line from here till here, which is 6 to 42, 36. Plus second parallel line, which is starting from here and ending at 42. So that becomes 42. And then multiplied by height. Height is the distance between the two parallel lines we just wrote. Distance between them is 8.2. As simple as that. Just solve this. 4.1 multiplied by how much? 78? Yeah. 4.1, which will be 319.8 meters. You can write it as 320 meters. Show that V is 7.84. This one, V is 7.84. We know that the distance covered during this section of the graph is 319.8 that we rounded off to 320. So what is left for this part? For this part, we are left with how much? 80.2 meters, right? That means the area of that white part is 80.2 meters, and that is coincidentally a trapezium again. So that's what we will write now. The area 80.2 will be equal to the area of the trapezium, half first parallel line. This time the first parallel line is this vertical line, which is 8.2, 8.2. Second parallel line is V. You guys did right. This is V. Yeah? That's second parallel line. And multiplied by height. What is the distance between those two parallel lines? This is the one, which is 10. And let's try to simplify this. This becomes 5 and it divides 80.2 by 5 equal to 8.2 plus V. Leave V alone and that becomes how much? 16.04 minus 8.2. And if I use my calculator, I must get 7.84. Please confirm, I'm sure about this. The final part, we calculate the deceleration of the sprinter in last 10 seconds. That means 42 to 50 seconds. That is the deceleration. Let's extend this line. They are asking us the gradient of this line because the gradient of a VT graph gives us acceleration. It's going down, that's why it's deceleration. To find the gradient, we should know the two coordinates at two places on a line. So let me write the coordinates of these 2 points. We know this now. 42 is the t coordinate and 8.4 is v coordinate. Similarly here it will be 52 comma and we just got 7.84 and we have to find the gradient. 8.4, do we have 8.4? No, 8.2. 8.2 minus 7.84, that is the second one, and T2, because corresponding to 8.2 is 42, so 42 minus 52. So it will be 0, 20, 16, 0.36 over 10, negative 10. So clearly the acceleration comes out to be negative 0.036 meters per second square. Since they have used the word deceleration themselves, so there is no need to write negative. You can write 0.036 meters per second square. Negative would be written if it was acceleration. Question number 5. A block of mass 2.5 is placed on a plane which is inclined at 30 degrees. They have shown it here to the horizontal. The block is kept in equilibrium by a light string, okay, with tension T in it, okay. The tension is T. Coefficient of friction between the block and the plane is 0.25, 1/4. The block is in limiting equilibrium and is about to move up. This is very important. Move up. When something starts to move up, the friction is downwards. That is a truth. Find the value of T. That's what they're asking. All right. So since it is in equilibrium, the forces upwards will be equal to forces downwards. One of the forces downwards is friction. What is the second force? Second force will be the component of the weight of this. If the mass is 2.5 kg, weight will be 25 Newton, 10 times that. So the component in this direction will be 25 sine 30 degrees. And sine 30 is actually half, so we can write it 12.5 newtons straight away. Okay, don't write this, write its value 12.5 newtons. Okay, what is the force in this direction? This force will be T cos 20 degrees. The horizontal x component of, we should not call it horizontal, x component of T, tension, will be T cos 20 in this direction, which will be responsible for this block to move up. Because there is a friction here, we must know the reaction force upwards. Usually, this reaction force is equal to the force downwards, which is the y component of this weight, 25 cos 30 degrees. Not this 20, okay? This 30 is the one that is causing this component to come. But this R will not be equal to this. Why? Because this tension also has a component in this direction and which will compensate the remaining of this. So it will be T sine 20. The cos component of T, which is the x component, is T cos 20. The vertical y component will be T sine 20. And this R will be affected by this component. So let's find R before doing anything else. So 25 cos 30, which is the y component downwards, will be equal to T sine 20 plus R. Okay, so in place of this R, we will write its value, which will be 25 cos 30 minus T sine 20 degree is R. This will be used as normal contact force. Okay, so now we have to equalize all the forces in x direction because it is in limiting equilibrium. For that, what are the forces downwards? 12.5 was 1, which is 25 sine 30 actually, plus frictional force. Frictional force is mu r equal to T cos 20 degrees, which is the upward force. So let's put the value of mu, which is 1/4, 0.25. R we just found out, 25 cos 30 minus T sine 20 is equal to T cos 20. And now let's values of all of them and we'll get T, because T is the only alphabet here which is unknown. So 12.5, 0.25 times 25 cos 30 will be 5.412. Now 0.25 multiplied by minus t sine 20 will be minus 0.0855 t equal to cos 20 0.939 t. So since t's are unknown, let's combine these two and add these two. This will be what? 17.912 equal to, when this negative goes to the right side, it becomes positive and they add up. When they add up, I get 1.025 t, and t will be 17.912 divided by 1.025. That comes out to be t is 17.475 newtons, which can be rounded off to three significant figures, 17.5 newtons. Question 6. A car of mass 1100 kg is moving on a road against a constant resistance. The force of resistance is 1550 Newton. The car moves along a straight horizontal road, okay, at a constant speed. So speed is 40 and that too constant, okay. Calculate in kilowatt the power developed by the engine of the car. So power is the applied force times the speed. Speed is known to us 40, but applied force is not. But the hint is here. The speed is constant. When speed is constant, acceleration is zero. That means whatever is the applied force, it is being balanced by the resistive force. They are equal. That's why F net is zero, because F net is mass times acceleration, and because of constant velocity, acceleration is zero. So these two forces are equal. So we can take resistive force equal to applied force. So they're asking calculate in kilowatt the power supplied. So power will be, applied force will be same as the resistive force, 1550 multiplied by 40. So it will be 2 zeros 620. So you can write, or 62 kilowatts. Okay, B part. Given that this power supply suddenly decreases by 22 kilowatts. Okay, we have how many? 62 kilowatts. So new power will be 62 kilowatt minus 22 kilowatt, which is 40 kilowatts. Okay, so new power is 40 kilowatts. Find the instantaneous deceleration of the car. What is the instantaneous deceleration? So now let's find, we know the power is force applied times velocity again, and it is suddenly happening. That means the speed was still 40 meters per second for a fraction of second. So we will use that because they're saying instantaneous deceleration, okay, and power is now 40,000. So what is applied force? That's what we have to find. It will not be equal to 1550 anymore because we have an acceleration now. Earlier the acceleration was zero. So applied force will be 40,000 over 40, which comes out to be 1000 newtons. So applied force is 1000 newtons, but resistive force is 1550 newtons. So what will be our deceleration? So we know that F net is equal to mass times acceleration, applied force minus resistive force. Mass is 1100, yes, 1100 kg. So 1100 times acceleration is applied force now 1000 minus 1550. So acceleration will be 1000 minus 1550 minus 550 divided by 1100. So that becomes minus 0.5 meters per second square. Are they using the word deceleration or acceleration? Deceleration they're using. That means negative is not needed. So you can write here deceleration is 0.5 meters per second square. Okay. The car now travels at a constant speed again up a straight road inclined at 8 degrees to the horizontal, okay, with the engine now working at 80 kilowatts. Okay. So newest power is 80 kilowatts, 80,000 watts, and it is moving up a inclined plane which is 8 degrees. The mass is 1100 kg, so 11,000 newtons this way. Okay, and force applied equal to power over speed. That's what we got in previous part, right? Power is 80,000. Speed is not known to us, so we'll write V. So that is the power, not power, the force which is being applied upwards, 80,000 over V. This is the power. And the resistive force, they have talked about resistive force, right? Assuming the resistance force remains the same, 1550 that means, okay? So 1550 Newton in this direction. But there will be one more resistive force which it has to overcome, which is the component of the weight, 11,000 sine 8 degrees. This will also be a resistive force in this case. All right. So, and speed is constant. Since the speed is constant, we'll use the same trick again. The forward force is equal to the resistive force. Applied force is equal to the resistive force in case of constant velocity because acceleration is 0. So let's equate this. 80,000 over V equal to 1550 plus 11,000 sine 8 degrees. So we can do cross multiply. V will come here, and these two 1550 and this 11,000 will go down, exchange place with V. 80,000 divided by 1550 plus 11,000 sine 8 degrees, and we can put this in a calculators and we'll get our velocity. By the time I do this, I request you to subscribe to my channel. I'm preparing this video on demand of one of my subscribers, and if you like and share this video with your friends, all of you will get benefited. I will be motivated to make more videos like this for you, and you can demand more videos and I'll prepare many such videos for you. Thank you very much. And the one I got here is 25.966 meters per second, which we can round off to 26.0, 3 second figures, meters per second. Question 7. This whole arrangement has been given in these sentences. Please read them. You can pause the video and restart when you're done. So it says that this mass is 1.6 kg, the B1 is 2.4 kg, it is released from rest, and then this B reaches the ground, okay, which is 0.5 meters. Given that the table is smooth, that means there is no friction whatsoever between A and the table. Find the time taken by B to reach ground. So to find T, we have many ways to do it, but the best kinematic equation we can use is S equal to UT plus half AD square. S, the distance it is falling is 0.5 meters. U is 0 because it was released from rest. So U was 0 plus half. A is a problem and T square we have to find. I'm leaving a space for A. Let's find A first. Can I do it here? So the force which is trying to bring it forward, let's say applied force is 200, not 200, 24 newtons. The weight of this mass is trying to move it forward. There is no force which is resisting it because this surface is smooth. It is as good as falling freely. But the problem is that this mass also has to be carried along. So we know that F net is MA, which is applied force minus resistive force. So M, because both the masses are moving, we will not include only 2.4. We have to include 1.6. So 2.4 plus 1.6 A equal to applied force is 24. There is no resistive force, so I'm not writing it. 2.4 plus 1.6 is 4. 4A equal to 24. Acceleration is 6 meters per second square. A free fall has an acceleration of 10, but because of this mass, it has reduced to 6 meters per second square, which we will use here. And now we can write 0.5 equal to 2 and 6 cancel, 3t square. So t square equal to 0.5 over 3, and to find time we'll square root both sides. Square root of how much is that? 0.5 over 3 will be 0.408 seconds. That's the answer. Part 2. Given instead, the table is rough. Okay, the things change now. That means if we have an applied force of 24 newtons, now there will be a resistive force which will be mu r provided by the table and the particle A. Yeah? So mu is given as 3/8. What will be the normal contact force R? So let's see here. Since there is no other component than this, so we can simply say that 16 Newton is downward force and 16 Newton will be upward force, so that they balance each other and this particle does not go up or down. So 16 Newton is the normal contact force which we will use here. So now our acceleration ma equal to F applied minus resistive force, our acceleration will change. So mass, both of them are moving. So their total mass was 4. A equal to 24 minus 3/8 of 16. We can cancel this. 2. 3 times 2 is 6. 24 minus 6. Let's do 4A. 24 minus 6 is 18. Acceleration will be 4.5 meters per second square now, less than before. Now, the question is, how far? Find the total distance traveled by A. So if we go back to the drawing, this A will go 0.5 meters till the B reaches ground and does not stop. Okay, by inertia it will move forward. So let's find what is its velocity at this particular stage when the acceleration we just got is 4.5 meters per second square. We know that v square equal to u square plus 2as. So v square will be, u was 0, it was just released, so 0 square plus 2 times acceleration we just got 4.5. This is the new one. S is 0.5 meters when it reaches ground, so 2 times 0.5 makes it 1. V square equal to 4.5 and V equal to square root 4.5, which we will not evaluate. Hopefully it will be used later. So square root 4.5 meters per second is the speed when both of them these two masses were connected, it B reached here at this square root 4.5 meters per second, and this A reached here square root 4.5 meters per second. Now, next thing is how far it travels after this. So let me try to do it here, and we'll use the same thing again. V square equal to U square plus 2AS again. Now, in this situation, this will become U because we are taking the incident after the B weight touch the ground and there is no more forward force now. So U is square root 4.5 and we have to square it. V we know is 0, it goes and stops. They said before pulley it stops, so V, final V is 0 plus 2 times S. We don't know S, we have to find S, and acceleration is again a challenge. So let's find acceleration again. So free body diagram, force applied, 0, nothing. Resistive force, we found it, mu, which was 3/8 of 16, and that was 6 newtons. So we have 6 Newton resistive force, no forward, so we can find acceleration now. Ma equal to applied force minus resistive force again. This time the mass B is not moving, so we'll take only 1.6 kg. 1.6 A equal to no applied force minus 6 Newton, which is resistive force. So acceleration is negative 6 over 1.6. We got it, the acceleration. Let's use it here. Minus 6 over 1.6. And now we can find how much further it will go after B had touched the ground. So this is square and square root cancel out, and we can bring this to the other side. So minus 4.5 equal to, can you cancel something here? No, minus 12 over 1.6 S. And finally, S equal to minus 4.5 times 1.6 divided by minus 12. I can use mental math in this. This becomes positive, this becomes positive. 4 times 3 is 12. 4 times 0.4 will be 1.6, and 3 times 1.5 is 4.5. 1.5 times 0.4. 0.6 meters. So it goes 0.6 meters further. So from here to here, A traveled 0.5 meters because of mass B. But further it went 0.6 meters. Total it moved 1.1 meters.